Okay, this is lesson 2.5, limits of sequences. And here we have provided. For A, 1, A2, A3, and so on. So as n approaches infinity, all right, as A to the n gets larger, moving down the line, it'll converge. It tends to converge on some limit. So what we're saying here is that for any epsilon, or all epsilon, either way, for all epsilon greater than 0, there exists an m, we'll call this m, greater than 0, such that n is greater than m. Well, where is m? Well, if m is at some point, let's say here, m, okay, and n continues and continues and continues. Lowercase n continues. As lowercase n continues towards infinity, we're saying that this, excuse me, this number is greater than this uppercase m. So we're setting a boundary, if you will. And so then from that we can state that our sequence, instead of f of n, we're using a of n, f of x rather, we use as an, the absolute value of our sequence minus its limit is less than epsilon. Then we can say that our limit as n approaches infinity for our sequence a to the a of n, so a sub n, equals to our limit. And we can say that an converges to the limit. So what we want here is, as our sequence, as our n gets larger, a1, a2, so on, the sequence converges, but it has to converge after some number m. So here, this point is outside of epsilon. If we're looking at this as epsilon, this would be limit minus epsilon, limit plus epsilon. But once it gets past this limit, then it's inside epsilon. So that's what we're trying. We need to find what this m is. That's going to be our objective in this lesson. And so that's all for our introductory video for this lesson.